Okay, the stream's gonna start in a moment. I'm gonna be doing things a little bit differently because last time I know it was kind of hard to keep track of me. At the same time, even if you have two screens, to be honest. Okay, so let me go. Where is he? Who's in here? Oh. You can join it. Okay, there we go. So do you guys see the stream or it's the one I linked before?
Let me see.
See if it pops up. I'm getting it ready right now on my side. I need to make some corrections to the code too because I want to change some stuff up. So I want to go more bare bones, at least for now.
Are you waiting for someone or no?
No, I was just messaging them in case they would pop up, but I'm not gonna wait for them. They haven't shown up for the last 3 sessions, so if they're gonna, if they want to join, they can catch up and tell me first.
Does anybody want to send me their repo file?
Repo? Oh, I can zip that up for you. Where is it? Oh, hold on a second then. Close. Here you go. That's the whole solution, so you just have to open it up.
Thank you.
Get the stopwatch out.
Wait, what is this for?
Oh, that's for Nick because he got Visual Studio reinstalled. He got the SSD installed.
Alright. Oh, nice.
Okay, got my nice little handy thing. Video looks okay from my side. Can I see the sound? Okay. I can hear myself.
Yep.
You should be able to hear yourselves too. I have you at 10 decibels. I'm gonna raise you to 9 because last video you guys kind of felt faint to me, so I'll give you a boost there. You're at 100. You're at 100 in Discord. Okay, so everything's balanced there. Let's look at the notes. That was the full outline. That was just that. That's after.
Do you know off the top of your head the extensions we're using?
Oh, the template? I can pass you those too.
Yeah, but also the extensions you had us download. I think it was like vShare or something like that.
Oh, these ShareX?
Not ShareX, but it's an extension within Visual Studio.
Oh,
Vim?
here I got you. VS Vim was one. You don't have to use it. It's up to you. If you're behind, you can disable it because it kind of is it's not easy to maneuver around with at the beginning. Usually what I tell people who don't know how to use it at the beginning, to just what do you call it? Keep spamming I to go into insert mode essentially.
Yeah.
For desktop development, this is what I have selected. Remember that there's going to be an IntelliSense thing that for some reason doesn't select for you.
Oh yeah, I gotta download that too.
Yeah, this is the workspace stuff. So I'll take a screenshot, I'll put it in TBF, V2 draft. There it is. And then there is, here's the ones I recommend. There's only 3. You can get more, but no need to get more right now.
Yeah.
There's a lot more that I used in 2017 for sure. Why we were in time 86 for some reason. I gotta get my old project out because that has all the crazy code. I don't think we're gonna go there. Oh, I need the commenting. Yeah, we're not gonna get there yet though. Okay, so now I got both. All right, so if you have available time, I wanted to try out the screen sharing thing on here and see if it's viable over DM for this at least. So I already showed Hazar how to do it before. There's a pin in TBF I just added, so it's gonna be the first one. If you click that link, you'll see the screen share option pop up.
Screen share. Alright.
And it'll change your window.
You see me?
Yeah. So for example, I'm seeing Hazar right now. But I wanted to see if it was viable because I have a bad feeling that this blocks you from seeing text chat. Is that true?
I mean, once you go into text chat, you would have to click on the link to get back again.
Yeah. So would you rather do DMs?
Yeah, but still, like, if you copy stuff in the DMs, just copy it also to the V2 draft.
Oh, no problem with that. In fact, if anything, we can just, yeah, I can do that. That's not hard. I'm pretty sure I've been keeping.
Keep like the stuff that you paste.
Yeah, I've been trying to keep it synced. If we see anything that's off, let me know. I'm pretty sure everything's from there. It's over here.
So are we gonna use the screen share? Is that...
Yeah, let's go to DMs. Just to make it easy, cause otherwise it's gonna be a pain in the ass for you guys. More so than for me, because you would have to keep constantly going back and forth. Okay, here we go. Yeah, cause at least this way you can keep.
What's
Hi.
going on?
Oh, we're about to do TBF.
Oh, okay.
We just called because of the DMs.
Why is my shit It's still ringing.
There you go.
Wow, sounds like torture. Let me restart this.
No problem.
Alright.
Nice. Okay, as soon as you're good to go, I'll start the timer.
Start.
Well, I'm like downloading Visual Studio. Do we need it right away?
Oh.
I guess we can go over like the stuff I fucked up while we're waiting. Okay, so let's try that. See how long it takes. So the most notable thing that I fucked up from last stream was I put it in the chat, so hopefully you guys read it. I kept calling while talking about the overview of the. Let me bring up Illustrator if I can. When I was doing this diagram overview, I kept calling the app the compiler instead, which is no good. I kept mixing them up because I was trying to talk too fast. Essentially, the only correction that really needs to be made is that whenever I said talking about the compiler, I really meant the app. So whenever I said the compiler communicated with the operating system, I really meant the app. I'm also going to go more into detail on what the compiler actually is, because I kind of noticed that I really didn't go as far as I should have on what it is. So, like I put in the notes, essentially the compiler is what translates C into something the operating system and hardware can make use of. So the C compiler specifically goes through a series of phases of translation, essentially, when it comes to getting your code from your raw C, like clean as hell C, to straight up binary code. So this is all outlined inside. If you go to language and then you go to, I'm looking for it, translation phases under basic concepts, you'll see the full phases, and it goes in detail on what exactly it's translating per phase. So the major ones that you should really know about is phase 4. Trying to see if phase 4 for sure. I'm looking at phase 5 right now. Nope. Phase 7 and phase 8. So phase 4, 7, and 8 are the critical phases. Everything else is just fluff that happens with all the other small stuff. You can go into it a lot, but phase 4 is a big deal. Phase 7 is where the real shit happens, and phase 8 is where the crazy shit happens with stuff called static and dynamic libraries. So phase 4 is really important. Basically phase 4 is all about those macros I was talking about before, trying to like expose you to them. That's basically, macros in C are technically called preprocessor. The reason that people just tend to call them macros is because in assembly, that's what you originally did. When you had a bunch of assembly instructions that you wanted to call like a nice name or something, or try to make assembly look cleaner, they would use macros, which are basically just placeholders for other code. That's why you'll commonly see, for example, in here, me using the define, what's called a preprocessor directory called defined, that directive basically means I want to define something with a name that's going to automatically replace the place where the name is with the raw symbol information that's part of the macro itself's argument, I guess you can say. There's a bunch of other preprocessor stuff because the preprocessor is really important for not just doing that defining stuff where you try to make your code cleaner, but also doing a lot of platform dependent code. So like if you're on Windows/Linux and you want to make your code multi-platform, the preprocessor basically makes that happen because it can do stuff called conditionals before compile time to see if it needs to compile Linux code versus Windows code. It can do include statements, which means that's basically the way we include libraries in C, which are basically other people's code or your own code that are different files into your file that you're currently using. So for example, we're using the standard library header, which is basically a nice formatted entry that tells the compiler what to include into this file so that we could use all the code functionality from that file within this file. All the preprocessor basically handles all of that. So yeah, if you haven't looked into phase 4, just keep that in mind. That's when it happens. So essentially, like for example, this code right now has a bunch of macros. By the time it actually gets done with phase 4, your code base, this same file, would have the entire C standard library inside of it right here, and then your code would start. All this stuff would be translated to regular C. So instead of having address here, it would have the type star here, and since void is the type, it would have void star here in memory block. If it had data there, it would do star address. So here's we haven't used that yet. Let me see if I can find something else. Returns right here, return type. So returns would get removed and exec flags would stay there, for example. That kind of stuff is essentially what gets absolved during that process. So at the end of the day, you get what looks like regular C, which, let me get it out, like this, essentially, by the time the phase 4 is done. So once phase 4 happens, the real compiling happens a few phases later in phase 7. So what phase 7 does is it doesn't directly go into binary or opcodes. It basically translates it down to assembly. And then it calls the hardware assembler, the one that it uses, or if it has its own custom one, it can use its own custom one, to translate that into what's called the instruction operations. So this instruction operations don't directly get fed to your processor and all that kind of stuff, though. That all gets handled by the operating system. So just so you get a full idea, I'm not trying to go too hard into this. When your operating system gets that compiled code, that operation set, and you try to load it as a process, basically the operating system makes a little box for it that's distinct from everything else, so it can handle it and control it properly and mediate it between all your other apps that you have running on your computer. And what happens is when you decide to execute that app, the entire full list of operation codes, which are imperative, because again, that's the bare bones code level, it's completely sequential, like one operation after the other based on what's in there. It will basically feed that for you and handle all that intermingling with the low level hardware, CPU, GPU, where that instruction should have gone, all that stuff. So basically that would be phase 7's main thing, just translating it down to assembly. And from there, phase 8 happens once the assembler has taken, depending on if it's statically linked or not. If it's statically linked, which basically means that you have some of the library code, like let's say you have the standard library or a boost library or some other library from somebody that you're borrowing from GitHub. Usually you get in what's called a static library. That means you're going to compile some of the code with you. So you may have like what's called a .lib file to help you out. Again, I don't expect you to understand all this. This is just a buffer. What essentially will happen is that code will be mingled and combined during the linking process. And let's say you have something that's more distinct. So like, let's say something that's been completely recompiled into what's called a dynamic link library. That dynamic link library is just, you've probably seen a DLL file with your games and stuff. It's a giant library file that's already in operation code that has a bunch of what's called access areas for functionality that's basically outlined for that library that you can have your program's functionality route to, essentially. So you'll see a bunch of game engines using this and stuff like that. The reason people do this is because it makes an extremely stable library to use from. So you'll be using these things a lot. Just the reason I'm giving you an idea of what these are is because in the future, if you go into real coding, you'll be using a bunch of these a lot over static libraries to make sure that you don't accidentally fuck with stuff that you don't want to. So that basically goes over the important phases of the translation. That's the only thing I wanted to emphasize, really. The other thing I mostly did since the last session, I made a full just let me go through this real quick. Yeah. I'm going to be removing some stuff from the code, but that's only when you have your Visual Studio set up. I'm basically going to be removing type depths for now because that's an ease of use thing and goes over a feature set that's a little bit higher than than what you would consider the lowest level of C. So the only reason I'm removing it for now is because I want to show you with Hello World what C as close to the metal could possibly look like versus using features from C that it provides you that's ease of use. So we'll be removing those soon. Other than that, I did write a full outline. It's kind of jarbled up right now. It's right here. I'm gonna write a better outline later. That's this a little bit cleaned up, but this basically right for now at least, this has the full outline of how this is gonna turn out. What are we gonna be doing in what order? So if you want, you can go over that. Basically, the summary of the entire thing is right now we're in the process of making Hello World. After we get Hello World done and I introduce ease of use functionality, or no, I'm gonna wait for that. Yeah, after we do Hello World, we're gonna do the timing system, and then during the process of making a timing system and making a very, very basic input, pull, and buffer, just so that we can take a single key of input to screw with our confirms. We're gonna introduce the higher parts of C's functionality that basically make things easier for you without you having to make a bunch of custom stuff in order to bring that out. So that essentially goes over any extra stuff I've done between sessions. So now I'm ready to work on code again.
Alright.
How's it going on your guys' side?
Chocolate cake, it's pretty good.
Nice. Okay, so
No, Visual Studios, we're good.
okay, nice. So let's go over the code we're gonna remove. So again, it's only gonna be type defs. So type defs are type aliases in C. They are important. They're one of my favorite features, but unfortunately they are an ease of use, technically speaking, and they add a security check called type checking that doesn't really exist in raw assembly. So because of that, I'm removing it. So to remove it, essentially, let's see where the things we need to delete. So we're gonna delete this thing called alias right here for now, or you can comment it out. And this thing right here, we're gonna be changing this definition, so I'm gonna comment that out for now. We're gonna be using macro for this instead. So we're gonna define. We're also gonna remove enum. We're gonna be using all macros because this is how you would, if you wanted to alias something at the assembly level, you would be forced to use a macro, essentially, is what I'm trying to get at here. So that's why I'm doing this. So everything that we had that was an ease of use, I'm completely removing for like hardcore as hell. So first thing I'm gonna define, so that we can bring back some stuff, is we're gonna bring back the exec flag success. So again, that was just a number that was given a name. We can still do that with macros. So I'm just gonna put 0 here. And basically that means that for every place that exec flag is, it's gonna put a 0, which is basically what enum did anyway. So there's that. The next thing we need to do is we need to define exec flags, and this is gonna be replacing the int. So now we can pretend it's a type, or just give meaning to the number that we're gonna be returning, but it's not strongly typed. C will not be checking that hardcore. So, and the last thing we need to do is we want a nice name for bool, so we're gonna name the bold macro have the same meaning as the bold type, because we're not gonna use this piece of shit they gave it.
I don't have that much of a problem with it.
Hey Zard, why the fuck can't they just do one thing right? Something so simple as name the bool right. I'm sorry. Okay.
Underscore capital.
Okay, the next thing I'm gonna do is we're gonna name this malloc something else, just so that it's easier to understand what the hell it is. I'm gonna grab that from somewhere else if I can find it. Almost got it. Hold on. I was messing with so many of these files. Here it is. So we're gonna call that a manage allocation. So we're gonna define another alias, define managed allocation, and we'll give it a parameter just so we can give the parameter context. So the parameter for managed, oh no, sorry, not managed allocation. Fuck, where is it? Sorry. I have it in Discord at least. I'll get that real thing I wanted. Okay, allocate, yeah, that's what I wanted. Allocate memory, and then size of number of bytes to allocate. So that tells us exactly what we're doing. So what you're gonna do is just gonna place the malloc here, and then for its parameters, you're gonna put the number of bytes. And this is exactly how you would, if you need to relabel what's called a routine in an assembly, this is essentially the way you would do it if you had a low-level assembly. Modern assembly nowadays is not like that. I'm just showing you low-level stuff because they have a lot of high-level functionality. In fact, I think in MSV and MASM and NASM, you can write some C code inside assembly, so they kind of just go hand in hand. So there we go. I think that's everything I wanted to do. So now I'm just going to replace Magalik with that. Yeah. So from here, we're basically, yeah, we're back where we were before. So reviewing from what we did before, we were in the process of starting with our entry point. So an entry point in assembly would just be a label that I don't know if they'll actually call it an entry point. It's usually like a dot entry or launch or something there. And then everything after that is executed in order. So that's the way we're going to be treating this from now. And the first thing we did was we told essentially the what we were trying to do was declare that we wanted to have an address that would store the address to a memory block where we're going to allocate. So then after that, for the memory block, we called the allocate memory function, and we told it we wanted to allocate enough to store a boolean and 13 characters. And that's what we did. If you don't know fundamentally why this thing says number of bytes to allocate, because you may be aware of something called bits. Why wouldn't I just allocate by the bit? The reason is because at low level memory, you don't have direct access to bits. You only have access to per byte essentially. And even that can get fudgy depending on word size essentially. Usually most memory maps that we have on the hardware level can give you access to per byte. And a byte's size is usually 8 bits long. So we can allocate by 8 bits for everything. So in this case, a bool is 8 bits or 1 byte, and a character is also 8 bits or 1 byte. Even though they store completely different types of data, that's just the way they decided to do things at this level. And since we want to store 13 characters, we do 13 bytes plus the bool, it's 14 bytes, and that's why when we did the debugger, we had 14 bytes allocated in the heap map when we ran it, which we can do again if you want to try again and see what that looks like. If you forgot, just press F11, and there's the address, because that means basically essentially the same thing that happened before. The app asked the OS, okay, for my heap, could I get some 14 bytes allocated over here? And the OS goes, here you go. Let me give you back the address. Engine's like, thanks. And since we weren't retarded, we stored that address in something we can reference called the memory block. And we can now see that address there. And if we do heap profiling and we take a snapshot, so long as you did the snapshot before and after, because otherwise it can't tell what happened, like just now, it can tell you that you just allocated 1 byte.
I'm getting an error.
You're getting an error? It might be something you typed. Let me go look at your screen real quick.
Yeah.
Because I know we just changed quite a few things. Scroll up for me. Let me see if I can... Here, yes. I'm looking at... Who am I looking at? Oh, I need this screen share for me so I can see.
Sorry.
No problem. Oh, it's blurry. See if you can change the resolution. I think 720p should do it. I don't know. It's usually... Is it on here? Yeah, it's on the... When you screen share, it asks for stream quality. You have to be careful what you give it. You can also do it by the app.
Yeah, this just disappeared. Let me do this. Yeah, it is on 720.
Weird. Oh, there we go. And that's, I think, a little bit better. Yeah, I can read that. Perfect. Okay, so let's see what's going. You don't need another / there. I saw that you have them. Let me see if I did that. On mine. Yeah, you don't need another / after that Malik. What the / means is consider the next line as part of this line. Is basically what the Malik does. Make sure that if you do a / for a macro, there is no white space after the / So that's a very delicate thing. That's why I'm just making sure, because otherwise it will break things. You have to check each one. Okay, so that's looks safe to me. I'm looking around to make sure. I don't see anything weird. Take out that enum flags. Comment that out as well. I didn't. You can highlight it. Let me show you a shortcut. If you highlight the entire thing.
Hold on a sec.
No problem. Constant.
Damn, why is that shit so blurry?
It's
Anyway.
fine, dude. It's cool. I can read it. That's all that I need to do. So if you highlight the entire enum definition, I'll show you a shortcut to comment it out, because you don't know it yet. Open it up. For some reason close it. Okay, now press Control and keep holding Control. K U. So you hold the Control and you consecutively press K and U. And now, K and C. K and C comments, K and U uncomments. So K, then C to comment, and then K, then U to uncomment. There you go.
Cool.
So now that happens, go down. Want to see what's down there to see what possibly could be causing that. Your memory block looks perfect. Go back up. Just want to double check the stuff on top. You have all my functions. All your stuff looks purple as hell. So try running that.
Yeah, that works.
Nice. So you didn't have a breakpoint. That's why it stopped automatically. So just breakpoint the line of the memory block getting allocated.
Alright. Would that be
The gray space right there. Oh, you almost did it. Right there. Double click that.
Oh, okay.
Perfect. So now if you run it. Okay, don't do anything yet. Take a snapshot. So go to memory usage. There you go. Yeah, you're getting the hang of it. Heap. Which is that little chip looking thing to the top right.
Oh, okay.
And then you take the snapshot, which is the camera icon. So now we have a reference. So now we can do a relative difference. So press F11. Not continue, because that'll keep going. We only want to do one step. Now take another snapshot. Now you can see that you allocated. You can also see that your memory block is holding a proper address now.
Yeah.
So yeah, that's the allocation. So we're back on track. So now what I'm going to do is don't want to keep it like that. So one thing that we want to try to avoid when we're doing proper memory management, thankfully we have an OS to help us right now, because otherwise we would be having what's called memory leak hell until we restart the computer. So what essentially happens is we're doing memory very manually, which means we allocated it, but we also have to free it. If we don't manually free it and we had the program keep running forever, you would have what's called a memory leak if you didn't keep track of that memory you allocated. So let's say you lost the address. There's no way for your program to ever reference that address again to that memory, so you can never free it. That's one of the biggest dangers to see, and that's why that memory profiler is so important, because it'll prevent that from ever happening. So now what we're going to do is essentially introduce a function for deallocating memory. So since I want to keep the words the same that I'm saying, I'm going to define the deallocate function. as a macro. I'm gonna provide the macro parameter an address, and essentially the function in C is called free, and free needs an address, so that's a void star. So we're gonna provide it the address that we're gonna be putting with the macro, like that. So I'll give you some time to write that out, and then we're gonna use that right after our memory block. So right here on line 109, I'm gonna put deallocate, and since memory block is a direct address to it, we can just give it memory block, and it'll be able to do what it needs to do with it.
Can I see how you define the macro?
Sure.
And what does the free do?
The free gets that address it, and what it does is basically tell, so like right here's our engine. So the engine's like, okay, operating system, you know that piece of here's the address to that piece of memory you gave me earlier. I don't need that anymore. You can free that up and do whatever you want with it. So basically what the operating system says is, okay, I'll free it for you. So notice that right now we haven't allocated. So if I take a snapshot, it might show it. There it is. If I press 1F11, you'll see this green arrow down. So now we still have the address, but there's nothing there. If I try to do what's called a data reference, which I was going to show you what this is soon, it's going to give me a massive error saying that I'm trying to access null. Or in this case, an illegal indirection. Because, oh yeah, I know why, but we'll deal with that later. But basically, if I didn't have an illegal indirection, it would have told me trying to access a bad reference because there's nothing to use there. The address leads to nothing.
Yeah.
So that's what free does. It's just the other side of allocation. You're trying to free up the memory so the OS gets full control over again, and you're saying you're no longer reserving it for your use. So again, if you forget to do it and you're shutting off your program, the operating system will do the freeing for you if it notices you didn't deallocate properly. But you don't want to do that because it's very bad practice, and if you have a long-running program like a game engine, that can get very bad very fast. So eventually we'll make proper smart structures that will automatically do this garbage collection for us, and C even. So we won't really have to worry about that for most of the engine. We'll get to that soon. But now let's get to actually trying to print the character to the screen so that we can actually have a proper hello world. Because now you have the basics for allocating, deallocating memory. Now let's manipulate that memory. So in order to do the hello world, we're only going to be using these characters here for now. The bull's nice, but that's more for looping later. So I'll get into that another probably next session if we don't have time. Hopefully we will. So back to the heap here. We have 14 characters. We want to store this sentence here, hello world with an exclamation point. So now we need to get that memory and start formatting it for it. So remember that the memory block, we wanted to reserve the first byte, the first 8 bits of our memory to bool, and we only want to use the next few bytes afterwards. In order to control that at the lowest level like this, when you have a single block of memory handling all your information in this kind of way, you have to make references to the position in memory that you want to address as a different type of data. And this is essentially what actually happens with the operating system and stuff. It tries to be efficient with its allocation, because what they don't tell you is this thing right here, and this is why JavaScript sucks. Allocating memory is a bitch for the computer to do. It is a monstrosity, inefficient process to do. So what everyone tries to do when they try to make an efficient program, they try to do this function right here as little as possible. So they'll try to do as many efficient allocations as they possibly can do, and deallocations. They'll try to make use of whatever memory, fuck around with it, change the type that they possibly can, so you don't have to call this piece of shit. Because the whole reason our processors have multi-cores right now is because how hard it is to send data to different places. It's not our what's called our ALUs. Those things are fast as hell. The thing that keeps holding all our computer processing back is how fast we can transfer data around. And JavaScript handles this very shittily. So, past that rant, like I said, we need to have a reference to the address for the character type that we want to mess with. So we know it's one outer bool. So the way we're going to do this is we're going to declare a new address store. We're going to say address here. We're going to put character. And then we're going to put message. Yeah, we'll just use message. So now we have an address to a message that we want to do, but we need to assign message the address to the set of characters. To do this, what we're going to do is we're going to say that message is going to equal memory block. Okay? But here's the thing. We're going to convert memory block to size to a how am I gonna do? Yeah, we'll just assign. I'm gonna do this as simple as I can. So we're not gonna do any complex math here. Just assign it memory block. So what now we have is that message is pointing to has the same address to the same start of the memory block that memory block has. But now we're gonna offset it. So now what we're gonna do is, remember, character is 1 byte. If you checked, you can check this in programming, but bool and character, I'm just going to tell you right now, are the same size. You can also check this with your allocation when you saw the 14 bytes. Because of that, what C++ lets us do is we can say message equals message plus 1. And what this is going to let us do is it's going to let us move to the very next byte in memory, the address. So now message will be pointing to, with the address, the first byte that we want it to be a character. So let's visualize this, because again, this is ultra low level stuff. So now if we go here, you're going to see we have a memory block and message. I'm just making sure everyone's here. When you're ready, I'll just press the debug and let me know.
Keep the debug in the same spot.
Yeah, because I'm waiting. I want to make sure Hazar is here. Well, you don't. You can put it to message if you want. Because we're technically already did memory blocks, so we don't have to keep going over that same one. I just want you to fundamentally understand addresses, so we're taking this as slow as we can, and addresses and data manipulation at the lowest level.
I'm good when you are.
Got it. So now we're going to assign message memory block. Watch what happens to message's stored value. It's going to be the same exact thing. Notice, though, that the type is different. We have a character now. So one of C's biggest features that some other programming languages before it had, but it took it to the next level, is called strong typing. So strong typing is basically a security feature. It's basically a way to make sure that you handle the data type the way you intended it to, by not allowing some weird shit to happen, and to also show representation when debugging like this, your data as closely to the way you wanted it to be represented. So right now we see this bunch of bullshit here, right, on our data, because that's when you allocate a memory, it doesn't do what's called zeroing out for you. So each bit's a flip-flop. When you allocate, the only thing the OS does is it gives you a nice reservation. That reservation doesn't get cleared back to a clean slate if it wasn't in a clean slate in the first place. So here we can see the old bullcrap that was on this memory and how it was flip-flopped from before us, getting reservation of it. That's fine because we don't really need to zero it out for our purposes. We're just going to be setting directly what we want. So if you press it again one more time, you'll notice you'll get a new address, and you'll notice that the number literally went from 0 to 1, because we literally went just one increment of a byte to the next available address to start putting our characters down. And then if you deallocate a course, you're going to lose reference to the data in those addresses. It's going to become bullcrap again because you no longer have reservation to that memory. So there you go. Now at this point, we have the right location in our memory block to start assigning Hello World to it. So how are we going to assign Hello World? Because we only have the address. How do we get access to the data? The way you can get access to the data, and this only works if you have a properly typed address. So like this one has a character. You must have a character, a fundamental type in order to access it, or one that, essentially, in order to get direct access to a data type, you must have a fundamental type named. Void is not a fundamental type. Void just means raw memory. Like, you just wanted pinpoint access to raw address to memory. You don't give a shit about the data. It's broken because then you can do proper crazy memory management, but when it comes to actually manipulating data, C won't let you unless you have a properly named type that's fundamental. You can find all of them again in arithmetic types right here on C reference. So back to the code. The way to do this
is broken.
Huh?
My code is broken.
Oh, let me go look at it. Hold on.
Shout out to Scrubs. Can I see see that last define the free address?
Let me see what you're doing here. Oh, first off, take off the semicolon. That is a good thing to do, but not for a macro, because again, the macro is going to replace that. So you want to do the semicolon afterwards yourself, so that you know you closed it instead of having the macro do it. Because if the macro does it, it's hidden, so it just creates improper syntaxing of your code. That's one thing to worry about macros of, is you gotta make sure that it still follows syntax rules the way they're supposed to be conventionally followed, which you'll get used to, so you don't have to worry about it. Onto mine. It looks pretty much the same. Let me go. Let's keep going down. Maybe it's something else. Everything there looks good. Try building it after that fix. No, it's saying, let me see that. Int differs levels and direction from void. Undeclared identifier. Wait. Go down again. It's 116. You see how this is something important about debug. You see how it tells you the line number? It tells you the error, and it also tells you the warning. So you're getting a warning but it's turning into an error because your message is an undeclared identifier.
Okay.
Trying to see.
Lines on this bitch?
No, I know you have the same lines. It's doing an extra security check.
No, I'm saying, how do I see what line I'm on?
Oh, you don't see them.
Yeah, I see it online, but yeah, yours is like blacked out.
It's not his is fucked up. Go to tools, options. They probably removed that option as a default. I don't know why. In Visual. Okay, so go to text editor. Let's see if we can find text. Text editor right there.
Oh, it's its own thing.
General. Let's see if we can show line numbers somewhere. We need to find that. Advanced. They'll definitely let us do it. There's no doubt about that. We just need to find out where it is. Here, let me go look for it.
Yeah, I was gonna Google.
Yeah, exactly. Google's best friend. Yeah, I don't understand why Visual Studio wouldn't show that. It's insane. Text editor, all languages, line numbers. All languages. Click on that, line numbers. You see that black box on line numbers? Check that. Make it a check so it always happens.
Line numbers?
Yeah.
Why am I fucking blind over here?
It's right after word wrap. Yeah. There you go. Make it checked. Okay, now press OK. Should force it now. There you go. So 116's fucked.
Yeah, line numbers now.
So it's, I can't believe it's actually giving you that. That's a oh, I think I know why. Well, that doesn't help either. Get out of folder view. You remember how to go back to solution view?
Yeah.
Yeah, go back to solution view.
Found.
Oh shit. Did you open the project and not the solution? That's what. Close it. You might be missing some configuration stuff too. That might not be helping. Open the project or solution. Okay, now go back to the folder. Open that SLN.
Yeah.
No. Back the SLN file. That'll give you the solution and the project.
You should only open.
Yeah, press OK. You're good.
Okay. I got your virus.
All right, so open execution. Let's see if it runs. Oh, yeah, okay, you're 64. Try running it.
Did it change?
I don't think so.
Yes.
Well, it might have. Well, definitely give you solution now. That's for sure. But it didn't change your. Oh my goodness. Go to. I guess I might as well go into compile stuff now, cause that shouldn't be happening. Go down. Cause it's not that. I know it's not your macros. You have the same exact thing I do. Go down more. I keep going to the bottom. I just want to see what the thing looks like again. Oh, there we go. Okay. I thought I was doing a security check. I thought we had to go change compile options. I didn't want to go there yet. That's after Hello World. Okay, so back to where we were. Get back to we already did the message thing, so let's get out of unless you want to test your thing, go test it out. After that, we're gonna start assigning the data a proper value set.
Is this normal?
You're just, you notice where your breakpoint is? It's right at the beginning of the function. You have to get inside the scope before it gives you something. So press F11.
Oh, whoops.
F11 will do it. So now it initialized. Go down. Keep going down. Do another F11. There you go. Another one.
And then +1.
See, there you go. Now you have the character there. That's initialized to the same address. Do the +1, and you'll see it'll go from D to D1, D0 to D1. Perfect. So it did exactly as intended. And the deallocate will deallocate. We already know that. So
I'm a programmer now. Look at that. That laugh.
Hey, you did some stuff that most people can't do, to be honest. Not gonna lie. Press stop. Alright, so let's start messing with the data inside. So to access the data, it's called a dereference operator. Now, because these stupid asterisks can get really confusing because everyone has their different way of spacing them and all that bullshit. I made a macro called data, and data does one thing: gets the data from the specified address. So what we're gonna do here is we're gonna say data message, so the data held by message, and now you have to keep track of this. And I know this is mentally taxing, but this is low-level shit. Eventually, I'll introduce ease-of-use concepts to make this easier. We're here. And pretend that this shit right here is your first character. And, of course, it would make some monstrosity. Can I not have a stroke? There we go. There we go. So this is the space we're going to be screwing with when we dereference data like you are right now. So we're going to assign that one space one character because that one space can only hold one ASCII character. The reason I say ASCII is because there's something called Unicode and other character format types. Those are bigger in size. They take multiple bytes and they have more symbols that we can use from different languages. The first symbol set ever made that was largely adopted is called the ASCII one. It's American's standard code for right there. So it's ancient, it's standard. Everyone fucking uses this for the first 256 characters. So C supports it by default with the char. So now we're going to assign the first character a value. So to do a character setting, we need to use something that's called a character literal. We could also type the number. We don't have to go that low. I want to show you what a literal is called because they use this in assembly, to be honest. No one fucking puts the damn number in. So when you press the single quotation mark like that, it will automatically put the closing one. This is called a character literal. It allows us to put one character there, and C, during the translation process for compilation, will automatically convert this character, a symbol, into the same exact integer value that it represents. So our first character is H, a capital H, because they do have different values. And we're going to assign that to our message. So now if you look over it, it'll tell you the H represents 72. And if you look at ASCII, it'll be the same exact thing. Okay? So now if we run that, and you go to the part where we're about to mess with the data, and you press F11 after we do that, you're going to notice something about your message preview of your data value or data. When you think of value, by the way, think of image or format or state of your data. Its value applies to any conceptual object that exists. It basically means the state of the object or the quality of the object compared to its other possible states. So that's the technical version of value. So now if you press F11, notice that that one specific byte changed to H. And if you go inside, 72H. Unfortunately, when it comes to viewing message this way, the preview for only the first byte of the message's address is shown. So, but this full preview here will show you the full, what's called string of your message for the amount of bytes that it's addressing. So from here, for the allocation, it's going all the way down to here. So that basically, if you guys successfully did that, we got our first character value assigned the lowest way possible. Okay? So now we need to get the rest of our message in there. So in order to do the rest of our message from here, we basically just have to keep going an offset one by one through the entire character data memory block. So to do this, you basically go data, and in here we're gonna do message +1, and I don't know if it's gonna allow that, but we'll try. I think I have to put parentheses there for it to like it. We need to put the E here because that's the next thing. It's gonna be a lowercase e. And to keep things nice and formatted, I'm gonna align the white space like that. And you're gonna see it's giving you it's complaining because we need to, in order for it to know that it's a it's a closed expression, we need to close the parentheses there. That's what it's asking for, if you saw red there. So now by doing that, what we're saying is the address byte after the original message's address byte, we're going to assign the value of E. And if you run that again, you'll see the E get put there. Again, you won't see in the preview, but you can see it right there. There's an H and then an E. And if you really want it to be anal and be able to see the entire thing, you can make another address thing called, if you really feel like you need it, you can make another address to a character address, and it can be called E, for example, and you can say that E points to message +1, and then you can put E here instead. And if you run that, now you can see H and E without having to, unless I fucked up just now, which I probably just did, to be honest. Brr. Fuck. Let's see what I did wrong. I think I need to put this like this here. Try that again. I think I skipped a step there. Yeah, I skipped a step. Sorry about that. So again, if we were doing this bare bones of fuck, you gotta assign E equals message, and then, or you can do the parentheses thing, and then you can say E equals E +1. And then if you did that and you ran it, you'll see they can see the E there and then the HE there because message also shows it. But again, I'm not going to be that going. I want to show you this operation here of offsetting it this way. So I'm going to keep doing it this way. I just wanted to show you that how much flexibility you have with how you debug and mess with your data. Okay. Now, what I'm going to do here is I'm going to follow this sequential pattern for the rest of them. So I know it's going to be up to 13. So I'm going to do the rest of them. And to make my life easier, I'm going to copy and paste this thing right here and paste it for the rest of them. For a few of them like that. And I'm about to introduce you to a new concept for data that you probably know about from before, but you never thought about it this way. So L here, because that's the hello. O here, like that. It's already fucking with my white space. I have to fix that afterwards. This is going to be straight up white space because we want a nice empty space there. So you just literally put space between the two single quotes. Then we're going to put a W for world. The O for world. Need to fill up some more addresses soon. So R here. Make sure to start incrementing this. So this is going to be +2. This is going to be 3 from the original. 4, 5, 6, 7. 8. There we go. Just aligning stuff. Notice how if you align it, it's easier to track what information you want to keep track of at a glance without having to really search for stuff. It doesn't, here it doesn't look like it makes a difference, but when we get to monster code, it will.
Go to Discord.
What? Oh, too fast? Discord, where are you? Damn it. Did my Discord die? Oh, here we are. What's up? Oh, thank you. Fuck.
Mm-hmm.
So much nicer. Okay, so now that that's done, we got the whole message. I'm just fixing this shit right now. Oh, I did it. No, I did it fine. I'm really anal if you haven't noticed yet about white space. Okay, so that's our whole message, but we didn't use all 13 characters. The reason we need a 13th character, we only use 12, is in order for our message to be recognized as something that's called a string, which is used heavily throughout any program. A string has what's called a null terminator. And a null terminator basically tells anything that messes with strings when the string ends. Otherwise, it doesn't know when it ends, and you'll be seeing trailing garbage whenever someone tries to mess with that string, or whatever function tries to mess with that string. So that gets added right here. Like that, the null terminator is literally a / with a 0. That's why it's called null terminator, because it represents null, I think, in ASCII. So there we go. We have our full message, and we can see it formatted. So let's see it formatted. So now if you run the debug mode and you cycle through each one of these one by one, ta-da! You'll see hello world. And if you run it and stop before the null terminator, you can see the garbage that would be there if you otherwise didn't use the null terminator. So all that trailing stuff gets removed, and now we have a clean string that we can use. Now you notice that we basically used an index to cycle through each of these. In fact, our first message could have been message plus 0. What you basically made here was an array structure, which is basically related types right next to each other. This is what an array essentially is in memory. It doesn't give it really shit. That's the only thing that keeps it together is the compiler, essentially keeping all the rules together with your types and stuff like that, and then making the array accessor. If you don't know what an array accessor is yet, I'm going to show you that soon, because this is the most tedious ass way of doing an array access that you can possibly do, and it's kind of a pain in the ass. But
why does my hello world look so retarded? Oh, because
what's oh, it looks fine. Don't worry about it. But now we have our message. Now we have something that we can send to console. So in order to send to console without having to deal with the Windows Platform API, which again would make our code unportable, you have to use something that's called standard output, which is provided by C. If you go to C reference, you can find standard output there. So if you go here, you'll find something called input and output support, and it'll show you all its input and output that it supports out of the box. That basically translates platform-dependent code like Windows output to console into something that works anywhere, and even on Linux, for example. So if you look through it, it tells you that all this shit will be in like a specific file. The header that it's inside of, that C reference tells us, is called stdio.h. So that's the library we're going to be including next. So in the right after the include for the standard library, we're going to be including stdio.h. And now we have access to the function we're going to be using. The function we're going to be using is called puts. It's the simplest,
Puts.
literally the simplest function I could find from C that doesn't use, that's not a Windows function, that prints a message to the output, standard output, which is in this case console. We're going to call puts prints because fuck that name. Print. So yeah, just call it print and then put puts there. That's it. And then yeah, leave everything else alone because we want to treat it like a regular function. So what put, unless you want to see what it does. So I mean, if you want to specify it. So here, what puts needs, puts needs, like, yeah, is a string, which in our case is an array of characters in its most basic form. So we have an array of characters, an array of 13 characters, 12 characters of a null terminator technically, but still. So now what we're gonna do is we're gonna call print and then provide it our message address. So from the beginning of the message address to the very null terminator, it will send each character to standard output and then enter a new line for us. That's the whole point of print.
Can I see
Okay.
the puts code real quick? Sorry.
Sure, no problem. Right there. Actually, I'm gonna make it. Should I make it? I mean, kind of been following. Let's see. Yeah, we'll keep it like this.
Alright.
Okay, so just put your print message here and get the debugger started because we might have something exciting pop up so no one has any compile errors. So when you're ready, get your message formatted and be right at the print and move your console somewhere that you can see it while it does the next execution. Unfortunately, we can't go to the
console?
Huh?
The debug console or the exe?
The exe console. So the one that's running right now?
Yeah.
Okay, so what you're gonna do now is while you're watching it, you're gonna press the print, and unfortunately we don't have direct access to the actual function. But we could. I'll show you how to get. I'll show you how to do one character at a time in a moment, using what's called disassembly. But first, we need to finish our Hello World. So this is gonna be the finale right here. So now, if you print,
Yeah.
ta-da! You printed a console. You did your first
Sick.
program in the lowest way possible.
I'm
It's
so
been real,
proud.
guys. I won't forget about you guys now that I took the time.
So now if you deallocate here, you'll notice your Hello World is also gone after you finish off your program because you're cleaning up after yourself. And there you go. That's your first program. Following tradition, you printed the Hello World. Now, keep this in mind. Even though you did Hello World in C, you technically did Hello World in Universal Assembly because we did it completely imperative using an entry point. We handled our memory completely manually for the most part, except for calling this print right here, which is basically what's called a procedural call, which we'll get to with the timings after the timing system, because we're gonna keep doing imperative from here on out. We're not gonna go to procedural kind of programming, which is using a bunch of functions until we get some stuff set up, because I want to get you comfortable with doing some what's called I don't know, they wouldn't call it routine calls, the go-to statement, which people like to avoid, but it's hiddenly OP for the right stuff, but you'll almost never use it. So, but yeah, that's your hello world. I think we kind of hit time though. Yeah, we just hit time. So at this point, it's up to you on what to do. Right after this, what's going to be happening is, I'm pretty sure I said after hello world, I was going to go into compiler stuff.
Oh,
Compiler stuff.
Because we were gonna start setting up the compiler properly because we've been using default compiler, and I want to show you how to get disassembly, so you can see what the assembly looks like for this code. Because we just made a hello world, so we should be able to see how our code disassembled into assembly, because the compiler can do that for us. And I wanted to show you how you can comment the assembly and all that stuff. You can do some really cool stuff with Visual Studio. But I wanted to make sure if we actually do that after, or if I had something else planned. Hold on. Okay. Maybe it was before I did that. I can't find it. Where did I put it? I did that. That's another day. Okay. I'm looking for it. Yeah, we'll do it now. So, well, if you guys want to continue.
What is it?
We're going to be setting up our compiler to look at assembly code from this.
And then?
And
What's
then
after
we
that?
should probably call it a day after that, because it's going to be a lot.
Well, no, I just wanted to see if it was something that was related to what we're doing now versus how we're going to continue after.
Well, once we get the disassembly down, you basically have a nice debugging platform. Probably one of the nicest that you can get, professionally speaking, even. Like, once you have a proper output, which right now your output doesn't really show shit, a proper warning setup for, like, really good warning setup that doesn't let you do dumb shit, and then a proper disassembly so that you can see what print's doing, just in case you don't trust something that's from another library, for example. Then you're good to go for the worst case scenarios, because you don't have to even worry about C at that point. If it's an assembly issue, you can check it, worst case scenario.
We're gonna go over the assembly right now?
Yeah, if you want to.
Okay, I just need a 5-minute break then. If that's cool.
No problem.
Alright, I'll be right back then.
That was a lot, though. How was that?
Pretty good.
Yeah, it was, I feel like for what we did, it took a lot amount of time. Like, I feel like the same.
Oh yeah, I know.
Same
but
amount,
look
like,
what we did.
Covered this entire thing. It should be like 25-30 minutes.
Well, I also went over. I didn't just do code. We went over code for the second half. Remember, I had to correct stuff for the first half, and also go over stuff I missed, like compiling.
Oh, okay. Well,
We also had to rehash because we skipped the Friday. Remember that? So Nick probably forgot half the shit by that point. So we had to go back and show him the debugger.
That's a good point. Yeah, that did take up like half the time. So sure.
Which I don't blame him. I mean, like, it's the same situation with Justin. He had to remember most of the stuff if the session's been too long from before. That's why consistency matters. Especially if you're doing this passive memory thing, which honestly, even if you're trying to actively memorize, if you're not consistent with it, you won't condition your memory and you won't be able to recall it. So yeah, that's one of the major reasons, because I'm pretty sure you can go back to the recording afterwards. I don't think we actually started till like 35 minutes into the stopwatch. 35 to 40.
Alright. Cause I literally just got Rage 2. And
Oh, I know.
So bad right now.
I know. I mean, that's why I asked you guys. But I mean, if you want, I'm hoping the debugger only takes like 15 minutes at most. Because all we're going to be doing is setting up output, setting up warning levels, and then showing you disassembly of only this. So it shouldn't be too much.
That shouldn't, yeah. It's fine.
I also got to comment this with more stuff. I had more comments for this stuff. I didn't put them. So I can start doing that here. Oh, that was another thing. No, we skipped that. So that goes here. I'll give you these in a moment if you want them. There. Oh, this was meaty. To be honest, I should have pasted you this because I already had it. God damn it. And I had these nasty ass comments here.
Oh, nice.
Here, I might as well paste it now. Let me get all this. So this is up to here.
Okay.
I'm gonna put it here. Hopefully it doesn't fuck with my spacing. Character too long. Oh shit, are you serious? Alright, I'll cut it off here then. Do it from there to there. Hopefully that's enough. Okay, good. Oh, I didn't put it in C. Hold on. No. No. There. Okay, so now we're just gonna do this. Perfect. Okay. It doesn't show up aligned here, but that's because Discord's doing new lines there. Oh man.
Oh yeah, I never asked why did we get the size of a bool for the first memory space?
Before in the original one, which I decided not to do, we were going to do a conditional to introduce a conditional, but I felt that it was better to leave the conditional out because I want to leave the conditional for doing our core loop for the engine and other stuff, because the conditional is the first thing we're going to use a conditional for is the go-to statement and basically showing how to flowchart our code using that and without having to use what do you call it, showing like raw as fuck conditional jumps and raw as fuck iterative loops without using for loops, while loops, or if else exactlys. You know what I mean? Very raw. That's what I was going to use it for originally, for the hello world, to print 2 hello worlds, but I decided to fuck that because I'd rather just show the hello world now and then I'll show you that other complete different concept after, when doing stuff like the timing system and getting the loop started for our engine. fact, let me go get the message. Comment there. Okay, now we got Fogley commented. I have the commented out stuff as well, which we'll add back eventually.
Yo.
Hey.
Yo.
Okay, ready to finish this off?
Did you say yeah?
Yeah.
No. Okay. Got it. So let's get this started. Let's get this a real ID setup for Seed started. So right now we have a basic IDE set up for noobs. Let's get the advanced features out. So if you right click your project right here and go to properties, you'll get this nice properties page for our configuration. We're not going to be setting it up for different configurations. This is it. You'll see a bunch of configuration settings, an insane amount. There's so many. We're only going to touch on a few. Definitely our platform tool set is 2019. We're going to be configuring for an application, so we're not changing that. If you go to debugging, everything looks good to here. We're not going to use a remote debugger. Let's check environment. Nothing there that we need. So far, yeah, we can keep this as all the same. VCC directories. We're not messing with files yet. We are going to come back to this include directories thing when we do make advanced file directories for our project when stuff gets real. But we won't worry about that for now. Let's go to C, C++. Okay, so we're not including anything else because we're just using C standard. My warning level set to level 3. We could go to level 4, but it's going to be a bitch if you do. I recommend... actually, let me just double check here real quick on my 2017. What do I actually use? I think I either use level 3 or level 4. I don't use wall because wall means wall. It's just a wall of everything possibly wrong. And the wall, by the way, hates standard library. Hates it. Microsoft considers most of the C standard library to be unsafe code. Just keep that in mind.
Goddamn.
Let's open Notation Engine so I can see what the hell I use here. Don't get intimidated, please. See. Okay, so I used warning level 4. Treat warnings as errors. Alright, well, before we actually use it, let me see what it actually does to our code to make sure that doesn't stop me from doing some unsafe stuff that we need to do for low-level modifications and stuff. Okay, so I'll let my code run. So we'll use warning level 4, and we're going to be treating warnings as errors because, again, most people here don't know proper C, and I definitely will fuck up sometimes, and you don't want to fuck with warnings. You want to keep your you want to keep your code as clean as possible. So we're gonna be pretty strict with our warnings. We're gonna be using level 4, and we did assembly stuff, so I didn't complain. So yeah, treat warnings as errors. So if you have a warning, we're gonna pretend like it's an error, even though our code could run fine. Let's keep going from there. So diagnostics. Let me keep that project open. Oh, I did. Thank goodness. This is my go-to. If I want to see how I did something, this is where I go, because this project had an insane amount of debugging. Use Caret. Yes, we're gonna be doing all that. So yeah, you change that to Caret level 4. Yes, press apply. Let's go on to optimization. Should be disabled. We want to favor fast code because we're an engine, and we don't care about us being large in size because we're not fucking developing for mobile. Hint Unity. Preprocessor. Okay, so let's check this. Yes, so make sure your floating point module, this is for Trial by Fire, is precise. You don't want to fuck with less precise floating points if we can deal with that. Because again, we're going to be having some physics engines in here, and if we want a nice and accurate gameplay experience with our mechanics, you want precision on your numbers. Where am I? Right here. So I did that. Language, we're going to be permissive. That's already set. I need to close this for now. Okay, we're not going to use value cast because we're going to be abusing shit, so don't enforce type conversion rules. We're not using latest standard because we're using C, not the C++ side. We're not going to include experimental because, again, we're not doing C++. Okay. So that is all the C++ side things. Oh, wait. Yes, we want to... So here's an important thing. So if we go to all options here, there's a... Should be ASM. Where the fuck is ASM? Oh, up here. If you go to assembler output, we want to output assembly with the machine code and the source. What that means, I'll show you right now. So when you build your project right now, in your project folder, there's a folder called Time64 because it's our configuration. And inside there's these object files and stuff. There's no assembly because it just went straight to this object thing, which gets turned into binary for our executable. So if we want to do assembler, which we just set the setting for, now if I build, in here there should be somewhere, is it out here? Am I in the right folder? It was supposed to, unless I'm fucking up somewhere. Is it this thing, the COD? Oh, yes. Okay, so if you go to your COD file, right here in the debug, here's the full assembly for our program. With our comments and our source code. So you get to see how the source code directly translates, even if you're not in debug mode. We're going to have this in debug mode too, but I'm just showing you what the Microsoft compiler lets you do. So this is how... so this is here's our includes in assembly. Here's our public main. Where's our entry? This is basically our entry point in this assembly. You can see how much more of a mess assembly is. Well, this is generated. Assembly can be much cleaner than this. Keep that in mind.
Execution.cod. I don't have that.
Did you we were messing with the properties. Did you set this right here in all options for C++?
Yeah.
Did you build?
No.
That's why. And once you build, it'll pop up. And I can move this actually to the Visual Studio. Let me do that right now, so that we have a nicer editor to look at this stuff in. Or it can ignore me. Hold on. We can open it up forcefully. You can go to your folder view if you want. Time64 debug. Or not there. In your project folder. Debug. And you should find a... Where the hell is it? Is it ignoring it? Are you serious? There it is. So
I
time
have an error all of a sudden.
No problem. Let me check it. Not pointer to message. Is it giving me that error? No. Just gives me warnings.
It was working before though.
Here, let me clear my build. Hold on a second.
Wait, it's giving you warnings?
Well, hold on. Let me see. I'm clearing my build. Nope. Let me see.
You're not getting any warnings?
Nope.
Because mine says warning.
Yeah, I can see you're getting a warning for the null pointer, dereferencing null pointer message. Here, go to your right-click your trial by fire again. I want to see something. Let me close this. Make sure I'm in the right view. Yeah, it doesn't care about mine for some reason. We're gonna fix that right now. Level 4 SDL checks. You treat warnings as errors. I'm trying to see why yours cares right now, because you have the same exact code as me. Go to your general C++. Oh, diagnostics format. Change that to caret. Yeah. Go to go to optimization now. Let me just make sure everything else looks good. Go to favor speed, Pfizer speed, favor speed. Press apply. Okay, just go to all options. That should show me everything. See what, because there shouldn't be much other differences. Go down, go down. I don't see what's wrong yet. Precise. And if you clear your build and you try building again, it's going to give you that error.
What do you mean by clear your build?
So under build, you can clean it so that it deletes all the build files and just doesn't try to build from what it has. So if you go to the build menu, all the way up top, the build menu, clean solution, then build solution again. Sometimes it gives you weird errors. No, it does not like it.
Puts undefined, assuming mistake.
Oh, that's puts undefined. Do you have an include? Go up. Go up again. Like, go all the way to the top. There we go. So there's your rear error. So right there, we're gonna add another library. It was the standard IO. So enter. Include stdio in the same format. So look, it just what with the alligator signs, the opening, closing, yeah, less than or equals stdio.h. See, so this is why warning level 4 is good to know, because otherwise it would have included it for you, because MSVC can figure stuff out sometimes, but that's not a good thing because we didn't want it to be implicitly known to include the puts that way. So now try building. It might still give you an error because of that dereference, but we'll see. You're good to go. All right, so back to the compiler options. I was just making sure that all options was good. So warning levels. Go back to notation engine. No, we don't need that. Yeah. So keep comments. We want that to be. Where is it? Where did it go? We want that to be yes. So we're gonna go to ours. Where's mine? Keep comments. Keep comments. Right here. Under all options for C, C++, press yes there. Let me go look for the last few. Optimize. Yeah, we're not optimizing. Everything seems good on that side. So now we're going to go on to the linker. So C++ is set up, the compiler side. So now we're going to go to the linker side of the compiler where it links up to other stuff. We shouldn't have to mess with stuff here because this is mostly for stuff we have outside. Our substance is already set. We can define a custom entry point here. We're not going to mess with it. We could, like, instead of doing the macro thing, we want to make a proper function name. We can do that, which we can do later, but we already have the macro, so I'll leave it as is. We already here you can see how you can change your machine. Windows compiler can compile to very different hardware. You can see that all here. You can do MIPS, ARM, lots of options. Let's go here to make sure. Okay, I think we're good there. So just to look for. I want to see this assembly. That's what I'm looking for right now. Which is a runtime thing. I think we have to go to compile debug options. So that's separate. So that's it for our compile properties there. So we basically got our solution set up there. So now, but it's not showing me the full build that I'm looking for. There's a version of the output for your build that's insanely detailed. That's what I'm looking for right now, essentially. I'm trying to see why it doesn't give us that. That's not what I want. It's possibly because we're only using one file, so it doesn't need to. Okay, I think we're good. I'll get back to that later. So, options. This hopefully be the last thing here. Where's debugging? Right there. You see this thing called here? Enable address level debugging. So, right here we're going to also check this thing called show disassembly if source is not available. Now we have access to disassembly at debug for print, for example, which I'll be showing you in a moment. So once you click that and you press OK, now for the real OP bullshit. So
hold on, I had you paused. What's the setting?
Under tools, options, debugging, general, and then under general, right under enable address level debugging, check the show disassembly if source is not available.
Oh, under tools. Damn.
Yeah, it's a different thing. I was looking for it in the properties earlier, but I couldn't find it, so I went over here and I found it.
Okay. Tools. You said general what?
Debugging, general, enable address level debugging. Oh, Hazar, you were asking me for keybinds? They're right here. For Vim. One thing I wanted to check, is it there?
It's weird. I don't see the option.
No, I don't. Okay. So wait, you don't have the option for disassembly?
No. Let me see it on yours.
Like this.
Enable address level debugging. No, I don't see it. In general?
Yeah, go up.
Oh,
Yeah, it's right there.
Yeah.
And then you press OK. So now that everyone's caught up there, press OK and breakpoint your print message. And only the print message, so we start there immediately. And run it. Now to show you disassembly. So you're going to want to make this most of your space because it's going to pop up down here. Or actually, how about we'll do this. Never mind. Keep it that same size. Go to your debug. Under Windows, there should be a disassembly option right here. Do you see that?
Hold on, my exe is blocking. Okay.
Right there. Click that. And now we can see the same source code, but in assembly. Live. So this is our full program again, in full assembly, live. All the way from the beginning to who knows what address. It's actually going outside of our code now. If we... Here, let me restart it so we can get back to that. Right there. So this is where we are right before print message, right? So, let me see. Is there anything else I should show while we're doing this? Here's our raw memory map, which I'll be showing you how to use that in a second. Because I don't think I've ever shown you guys this, anybody. I've used it before once. It's really raw. I used this to modify Far Cry 3 way back. To get a fucking pirated mod to work. Okay. Ready?
Insane.
So, I just opened a bunch of windows. I wanted to explain them.
Bert.
Let me know.
Do it.
Oh, wait. I'm waiting for Nick.
I'm so confused at what I'm looking at.
Okay, so I opened up a few windows. Let me go through them. The first one is called registers.
Oh.
That's one right here. These are your lowest. When I say lowest, the lowest type of memory your process can have access to. They're extremely fast. So you can see what registers values are being occupied right now. You almost never need to do this unless you're using something called a register in C, which you can dedicate an access to one of these if you wanted to. But again, you almost never do. Just showing you this exists. And you can see it being manipulated at the beginning of our program. I'm just showing you how raw this is. So again, you can see how those red number. You see the red? That means the changes.
Mm-hmm.
So you can see how the registers are being manipulated as your program goes. So there's that. I'm gonna close it because we don't really use this. Well, I'll auto hide it. There we go. We don't really use that during debugging. The other thing we don't really use is, well, you may use this actually. So, and you may use this assembly for really, really tough times that do happen. So, memory right here. If you go to a specific address that you asked for, so like that, boom, you can see where Hello World's located in your heap.
Oh wow, nice. Okay.
That's the benefit of it. So you can see hexadecimal display, you can see signed display, unsigned display. 64-bit floating point version of it.
Where did you see Hello World?
Let me go back to no data. I'm trying to get back to. There we go. No. Fuck. Sorry. Hold on a second. I lost the address. My bad. There it is. See it?
Oh, you're fucking searching.
Yeah, you click on the value there, copy it, put the address in, and instead of having to deal with these things, you can directly look into your heap with this. This is another reason why, and there's different views. I'm trying to show you all of them right now. You can view them as 2 bytes, 4 byte, a 4 byte integer, 8 byte. You can put it into hexadecimal mode, signed mode, big endian mode. All these have meanings.
I can read it.
But yeah, it's all there. Usually the most popular, which is why this is being used right now by default, is hexadecimal with 8 byte. I mean single byte. So each one of these is a 1 byte, and you can see the letters. And here's the 72. Right there. So that's probably the start of our hello world all the way to the end, which is probably the 00 or something there. We can probably, it's right there, whatever that fucking thing is there. So again, I'm just showing you another raw way of looking at your memory block. If we want, you can go right there. So is there another way I can do? There's Unicode. That doesn't work for us right now because we're using ANSI. But yeah, there's your memory. Just in case you needed to like see what the fuck's wrong with your heap and you're not getting good enough information from your locals here, you can view your raw heap like this. Just showing you that exists because I don't see it used often. Now back to our disassembly here, okay? Those windows are out of the way. If you go to your print message right here while it's running, if you press the F11 now that we have the show disassembly, it'll go. Well, it should have gone. Unfortunately, it didn't. Let me see if I can force it. If you click here, it should go one at a time. So now you can see what the print message is actually doing, okay? So first thing it did was it moved the message, the address of the message to, which is a keyword. It's stored in something called a keyword, into something called RCX. RCX is a register. Should be right here. So it's storing the message address there. And then what it's going to do, it's going to call a Windows command from assembly that you send that message value, the addresses, that's the address. If you go look at the value of RCX, it's or not. Wait a moment. What is that then? That might be a specific image. No, that should have been it. Well, ignoring that, because it's probably going to put it in there now. Essentially what that call is supposed to do, it's supposed to say call puts for that whatever's inside RCX. Okay, so I'm just showing you what puts does, since we don't have access to the standard library. There's your raw program in assembly, and you can view this from the beginning. So if you wanted to see how your program turned out and see how efficient it is, and if you wanted like let's say you wanted to see if your structure was actually well generated in assembly, you can view it this way. So here's our allocation call. It takes 3 different instructions in assembly to make that thing happen. Again, make sure to click on the disassembly window. It's going to skip lines. So here's for setting all our data. Each one takes 2 moves, commands for each of those. So you can see how much C is doing for you and how much is not doing for you. That's the emphasis being made here. But yeah, that's it. That's it for today. That's more than enough information. Well, and we're way over time.
Refresher on that next time.
But I hope it kind of gives you like, I'm pretty sure no one's done that with you.
I don't know.
That is
never gone into fucking assembly through.
That's
Visual
fundamentals. Now we're gonna be building. Now that we have a full guide on our, I've given you full outline, full context of what you're doing here, and how it relates to the lowest level. So now we can fundamentally start constructing a proper idea of how to code at this level. And again, you saw, like, if you really wanted to make things efficient, you can now. You can worry about your structure properly. You can check what things are bad to do, what things are good to do because they create less instructions, stuff like that. And the drawbacks and benefits of each thing, because sometimes you'll sacrifice more instructions if it means your code is more readable, or you can do something called a comment that shows the ideal form of your structure, but then you do the more efficient version because it's more efficient. But at least the ideal comment structure within a comment, for example, would tell the programmer what you meant to do with this more, but now you're doing it more efficiently, which I almost never see done. So there you go. You already have a better foundation than most people in coding by a long shot.
Alright.
So yeah, next time we're gonna be making what makes a game engine, a core engine loop. So we'll get into actually doing the engine next. Okay.
That was fast.
That was fast.
No, just like the curriculum. I like jumps.
Well, yeah, I mean, like, this was slow we're taking it slow at the beginning, but once everyone gets the hang of it, we're gonna be going along pretty damn fast, because I mean, it's the same thing as other stuff. It's like once you get the basics down, which is the one you're supposed to be slow at, that people don't be slow at for some reason, you're supposed to start really speeding up. But yeah, that's it. If you need my file because whatever reason, I put the comments. I'm gonna screenshot this just in case I missed something. I put a lot more comments. I try to paste them because I forgot to do them while we were doing it. Where is my? There it is. There we go. So there's the last few comments I've added. I pasted some of them. If I'm missing any that I'm supposed to have pasted, let me put that in the real chat. Right there. Let me know. Jin was asking me about something. Gotta go check what he's doing later. That's it. I'm gonna